Actually, that's a terrible way to start. Computer science is a terrible name for this business. First of all, it's not a science. It might be engineering, or it might be art. Or we'll actually see that computer, so-called science, actually has a lot in common with magic. And we'll see that in this course. So it's not a science. It's also not really very much about computers. And it's not about computers in the same sense that physics is not really about particle accelerators. And biology is not really about microscopes and petri dishes. And it's not about computers in the same sense that geometry is not really about using surveying instruments. In fact, there's a lot of commonality between computer science and geometry. Geometry, first of all, is another subject with a lousy name. The name comes from Gaia, meaning the earth, and metron, meaning to measure. Geometry originally meant measuring the earth or surveying. And the reason for that was that thousands of years ago, the Egyptian priesthood developed the rudiments of geometry in order to figure out how to restore the boundaries of fields that were destroyed in the annual flooding of the Nile. And to the Egyptians who did that, geometry really was the use of surveying instruments. Now, the reason that we think computer science is about computers is pretty much the same reason that the Egyptians thought geometry was about surveying instruments, and that is when some field is just getting started and you don't really understand it very well, it's very easy to confuse the essence of what you're doing with the tools that you use. And indeed, on some absolute scale of things, we probably know less about the essence of computer science than the ancient Egyptians really knew about geometry. Computer science, in some sense, isn't real. You see, when an engineer is designing a physical system that's made out of real parts, that the engineers who worry about that have to address problems of tolerance and approximation and noise in the system. We don't have to worry about tolerance, and that means that in building a large program, there's not all that much difference between what I can build and what I can imagine. So as opposed to other kinds of engineering where the constraints on what you can build are the constraints of physical systems, the constraints of physics and noise and approximation, the constraints imposed in building large software systems are the limitations of our own minds. So in that sense, computer science is like an abstract form of engineering. It's the kind of engineering where you ignore the constraints that are imposed by reality.
A wise man once said that television was supposed to bring Shakespeare to the masses, but instead we got reality TV. Well, similarly, computers were supposed to bring intellectual amplifiers to the masses, but instead we got fill in the blank. Computers are not calculators. Computers are not communication devices. Computers are a meta-media. They are simulating machines. One of the tragedies of the field is the extent to which computers exist solely to simulate older media. It's worth considering how many apps are just simulating paper, for example. It's tragic because we all know that computers could be doing so much more. We could create new types of media. We could create new ways of amplifying our collective and individual intelligence. To combat the increasingly epic problems of the world, we need to build new tools, new intellectual amplifiers, and create new media. Even if we can't solve the problems ourselves, we can create a foundation for the generation that comes after us, for them to have the ability to solve the problems that emerge for them. If you're a software developer or someone who's interested in being a software developer, ask yourself, do you want to build the tools for the next generation? Or do you want to spend your life building a Skinner box to hook people on products that exist solely to sell ads? Don't forget to like and subscribe for the algorithm.